Can you check to see when the next exam is?
No. 12 days. Way too soon.
Yeah. There are 3 days to cover this topic.
What?
There's 3 days to cover this topic and then we take our exam. So typically I can cover this topic in like 2.5 days. So then that leaves the back half of that third day in order for you guys to do, or for me to tell you what's going to be on the exam. The nice thing about this is you guys have already seen my exam, so I'll give you guys an idea about what it's going to be on that last day. The other good thing for you is I have to remember my dates correctly, but it goes Thursday is today. Tuesday, so today we'll do a bunch of background stuff, and I might get to an example. I'm not entirely sure. Maybe. And then Tuesday I will definitely get through one example, and then I'll probably start the other one. Thursday I will certainly finish it, and then we'll talk about what's going to be on the exam. And then you guys take your exam on the following Tuesday. So it's nice for you guys because you guys have the weekend, right? So you guys got lucky there. So what I have to get through this material in these 3 days. So today is going to be a new topic. It's going to be very, very, very similar to what you guys were just doing. So I have one thing that I want to do here. So the topic today is actually called a sampling distribution. Sampling distribution for sample mean. So rather than me just tell you guys what this is, I want to create one so that you guys have a better idea of what this is. Because this is going to be different than what we were just doing, and I want to be able to explain how it is different than what we were doing. So, let's do this. Let's do how far you live from campus. Okay. Sampling distribution of sample means.
Means?
Yes, sample averages. Is that
Okay.
easier?
I just couldn't read it. Those means or needs?
Sample averages. Sample means, sample averages, they mean the same thing. Alright, so what I want from you guys is I need how far or how long it takes for you guys to get to campus. How long does it take for you? Alright, so now I'm going to specifically label this. So x1, right, this is my first data point. This is this particular student, and they said 20 minutes. x2, that's you.
25.
x3, x4, 25, x5, 10 per. X6, yeah. 7. Okay, I could continue to do this. Right, but I think you guys get the idea, right? x1, this is my first data point. x2, this is my second data point. x3, this is my third. So inside of all of these things, they all vary, right? So with this, what would my x be? What's my variable for this particular instance? Right, so this is distance from campus in terms of minutes, right? This is distance from campus in minutes. Since I have all of these, right, and I could continue to do this with all of you guys, so I could actually make a graph of this, right? We can make a graph. If we wanted to, then we could talk about gaps, peaks, clusters, outliers, all the stuff that we were doing before, right? Just exactly like what we have been doing. Then, also, if I wanted to, I could add all these up and I could divide by however many that there are in here, right? So then I could say, oh, well, mu is equal to 18.3. Again, I don't know what that is, but just totally making up this number. But you guys understand, right? This is the average of all of you guys, and I added them all up and I divided by however many you are, and I got 18.3. Right? What is this? This is the standard deviation. So what does this describe? The spread. So a nice, easy way to do this could be variation between students. Variation between students. So what I mean by that is, if this is equal to 3, then is there a lot of variation between you guys? No, it means that all of you guys travel about the same distance. That's obviously not the case because somebody here is 8, somebody else is 30, so this is probably significantly bigger. Just make it 13. I don't know. 0.1, and then it makes it seem like that I've actually done it. It's kind of funny. If you want to convince somebody of something, just put a decimal point on there and just say it, and then they'll be like, wow, you definitely did not make up that number. All you have to do is put that decimal on there. But now this is going to describe the variation between each student, right? So the bigger that this is, the more variation that there is. The smaller this is, the less variation there is. Right? Does this make sense? This is all the stuff that we have been doing. This is a population distribution. The reason why it's a population distribution is because I'm considering all of you guys right here to be a population. There's no more of you, there's no less of you. So this graph would be all of you. This is why I use mu here, because it represents all of you. I represent a sigma here, because this is describing a parameter.
The larger the variation,
The more spread, the larger the number, the more spread out, the larger the variation. The larger the number, the more variation. Alright, does this make sense? This is what we have been doing. If this distribution turned out to be a normal curve, then we could do the whole stuff that I had just had you guys doing with that worksheet. We could do those 4 steps for all of it. Right, does this make sense? So now, I want to show you guys how what we're doing here with a sampling distribution is actually different. So this is where I need you guys to, we need to create a sample. And in fact, we need to create a bunch of samples. So I need an average, right? So now, I need X bar, right? This is an average. This is the average of what they are going to do. Right? They're going to ask a few of you guys how far that you live from campus, and then they're going to add up whatever those values are. They're going to divide by their total for that particular. Does that make sense? Then X bar 2, that's going to be you. This is going to be their average. Then X bar 3 is going to be you. It's going to be your average. Does that make sense? Okay, so then let's do this. So I want each of you guys to ask 5 students, other than yourself, how far they live from campus, and then find the average of those 5 students. Okay. Does that make sense?
Yeah.
Okay, so stand up, find 5 people, get 5 different data points, ask them how far they live from campus, and then add them all up and divide by how many.
Going to the school time. 15? I'm gonna say 25. How about you? 25. What was it? How far are you? 25.
how far are you? 25. You?
Alright, so without shouting me, do you have your five? Do you have the average of your five? Okay, what is it? 14.6.
23.
24. 23.
21.
What was it? 55?
Mine is high too, is that wrong?
God bless you. No.
Okay.
21.
13.6.
Thirty. Okay. So now, these are different from these. How are they different? What I'm asking here is, what are they describing? Over here, what is this X bar, or what is this X1 describing? One student, just her. X2 is describing just you. X3, X4. This is describing individual students. Over here, what are these? What's this one right here describing?
The average.
An average of 5 students. What's this one describing?
Another average.
Another average of 5 students. Just like this is one student, this is another student, this is another student, this is another student. So now, we're no longer talking about individual students. We're talking about groups here. Do you guys understand the difference between the two?
Mm-hmm.
So all those questions that I asked you on that piece of paper was all about individuals or an entire population. Now I'm going to ask you literally the same questions, but now it's going to be about a group. So let's kind of finish this. These values here, if I wanted to, could I load them up to SALT and make a graph of them?
Sure. Sweet.
Sure. If I wanted to load these guys up into SALT and make a graph of them, could I? Yeah, I could make it. Is it like contagious to sneeze? Should we all sneeze now?
Absolutely not.
I thought yawns were contagious. Now sneezes are. Anyhow, so if I wanted to, right, we can do a histogram, we can do a dot plot, we can do a stem and leaf plot, we can do also whatever those graphs are for numerical distributions for this. Can I do the same thing with this? Yeah, they're just numbers, which means I can do this and I can create a graph of this. This graph is not a population distribution.
Wait,
What?
you said, okay, well, but
This graph that I create with these averages is not a population distribution. It's a sampling distribution. Because the word sampling here just means that I take samples over and over and over and over and over and over and over again. And then I look at that picture. And that graph is now about a bunch of averages rather than just an individual. Does this make sense?
Mm-hmm.
Now, just like over here, these are just numbers, right? If I wanted to, I could add them all up and divide by however many that you are. Aren't these just numbers? Yes, these are simply just numbers. Can I just add these up and divide by however many, add all these up and divide by 21? Could I do that? Yeah, I could have one of you guys get on a fancy calculator, add all these numbers up, divide by 21. What is that describing?
The average per distance per 5 students, right? Just have to keep track of the 5.
It is an average
Of sample.
of sample, but I mean, doesn't it make sense? I mean, all these are all samples, they're all averages, so now it is an average of sample averages. It is different than this. This is a population average. This is me talking to each one of you guys individually, adding you all up and dividing by however many you are. So this notation does not apply over there because it's a different value. Does you understand how it's a different value? Because now we're talking about groups and not the individuals. So the notation for this is a mu with a little x bar next to it. And it literally means the average of sample averages. This is why I have that question on the exam about the notation. So this is different than this. It describes something else. If you hold on a second, I'll be done with it. Now, if I wanted to, over here, right, we could load all this up into SALT and hit that descriptive values, and we can get a standard deviation here, right? And this describes the variation between students. Here, I still need a number that is going to describe variation, but is it about students anymore? It's about the groups. Because who was the one that got 55? This, what is this going to do to this distribution? It's going to make it really wide now, right? So I need to represent that. Over here, this number right here describes variation between each one of you. The standard deviation for this is not going to describe the variation between each one of you, but the variation between groups. Make sense? So this, standard deviation of sample means, sample averages, this describes variation between groups. So we need a different notation. Right? It's still going to describe variation. It is still a standard deviation. But now, this is a sigma with a little x bar next to it. Now you can take your picture. Okay. Do you guys understand the differences between the two?
Oh, what was that? That last. Sorry, I was wrong.
Well, I don't know.
You should probably.
Oh, sigma with an x bar.
We should put sample distribution
Yes.
here.
These are all sampling distributions. That's what we're describing now. We're not talking about this anymore. We're now talking about groups. Okay? So this is why this next exam is so difficult. Because now, and I will get you guys this, but I don't want to do it today. This question right here was the one that we did last class. Right? About the teachers and
Salary.
made this one right here, 80,000, I think on the, what was the one that we had, like 65,000 or something like that? So, I want you guys to read question number 2. And I know it's I tried to make it giant. Because question number 2 is not like what you guys just got done doing. And there's one thing that points out how it's not. what's the information here that tells you that this is nope, right up here. This question right here is missing a piece of information that this one actually has.
Sample. I can't see that.
Yes. The sample in this one is given to you. Every single one of those questions I had you guys doing here, did I have 5 IQs or 10 IQs or 100 apartments or 75 students or 12 gifted students or 30 premature babies? Did I have a value with any of those? It always said all. That's how I know that this is a population. Because those are about, it'll either be about everybody, so it'll include the word all, or it will be about one. This one would be exactly the same type of question, but instead of finding one apartment in Ann Arbor, Michigan that's more than $1,100, it would be what's the probability of getting 12 apartments that have an average value of more than $1,100. It has a specific number there. It has a specific size. In fact, for us, what's the X bar here? I don't know. I don't care about what the X is anymore, right? The X was over here. X is about the distance students live from campus. These questions that we're going to be doing now, they're not about X. I don't care about that anymore. I care about this. I want to see how unusual it is for me to get a specific sample. So what is the X bar here? I'm fine. What did you guys? Yeah, okay. So I like that. X bar.
The average distance from school.
Let X bar be the average distance. Okay, I like that.
What students are going to school?
Not all students.
5. There are 5.
5 students.
Oh, so it's more specific, it's gonna be more specific then.
5 students drive to school. Alright. So you remember the rule for this one over here on all those pieces of paper where it said no numbers? Does this one have a number? Yeah. It specifically is going to, every single one of our labels for these is going to have a sample size. It's going to have a number. It's going to say 10, 100, 5, 4, 20. It's going to have a number specifically in the question somewhere, and we have to include it in the label. Right? This is a sample average. So X bar, let X bar be the average distance 5 students drive to campus. This is different from what we're doing over here, which is just let X bar be the distance from campus in minutes. This probably should actually be for each student, right, to represent the one. But this is 5. Okay, do you guys hate this?
Yes, but not too bad.
Okay, well, let me see if I can make it worse.
Great. Just
All right.
outdo yourself.
I know, I'm trying. Gotta get those student evaluations down really low.
The sample number will be found in the problem. The sample number will always be given in the problem.
Right. Because,
I
thought you were gonna say no.
well, because, couldn't I put one of these questions on your exam? Yes. Could I put one of these questions on your exam? Absolutely. Your job is to determine if it has a sample in here, you have to do all of them like I'm going to show you. If it doesn't have a sample in here, you have to do them all like that.
Like the first way.
Like the first way, the 4 steps, right? Label, shade, math, statement. That's all if it doesn't have a sample size. If it does have a sample size, for now, I'm going to slightly change it. There's still going to be 4 steps, but it'll be just enough to make you go, I hate you. And then next class, I'll add a whole other type of problem because we'll do all this all over again with proportions. So there are 3 different types of problems that all look identical. This one right here is a proportion problem that we cannot do yet because I haven't got to it. But I have put all those on exams. and your job is to determine which question is which. But pause for a second. Let's get through this. Our first step is still going to be label. Always and forever, it will still be label. But now, what am I labeling? I'm not labeling X like before.
X bar.
The X bar. So this should be let be the average of whatever. So then you make a note. Must include sample size. It must include the sample size. Now, step 2 isn't going to be quite like shade, but it has something to do with this. This is called conditions. All right. So for these conditions, what I want you guys to do is you need your super awesome computers. I'm going to take you guys on a little. We're going to surf the old interwebs. Either one of you guys brought one? Okay. I want you guys to stat key, all in one word. Stat key, STATKEY. Should bring you to something that looks like this. Hopefully yours doesn't have a circle on it. Then just click on that, and this brings us to something that looks like this. Okay, so I don't know if I told you guys this, but can I tell you guys this? This is actually run by a family of statisticians. They're called the Mach 5. Right, so that's why it says by Mach. So they teach statistics in a they use a lot of computer simulation, which I don't use. So this is a nice way for us to get across what it is that we're doing. So what I want to do is I want to click on sampling distribution, and I want to click on mean. Alright. So what this is over here on the right-hand side, it's got a population of, I don't even know what this is. Does it even say someplace what this is for? Oh,
Baseball.
in like 2019. Okay, so that is a bunch of different, that's all data points, right, for baseball players and whatever that year was. So what I want to do is this distribution here, this is like when I asked all of you guys how far you live from campus. And when I said I could make a graph of it, that's what they've done here. They've made this graph. Make sense? So if I was going to get all of your guys' distance, run them up to SALT, and make a graph of it, it might look something like that. But that's just all their data points. I don't care about that. I want to create this. So I want this website to gather a sample for me and calculate an average. So up there at the top, choose samples of size, let's leave it as 10. And then it says generate one sample. So I'm just going to click on that, generate one sample. And when I click on this, then I get one specific value. So you guys can go ahead and do this. Is your value the same as mine?
No.
No. In fact, should it be different? I mean, it's almost like over here, this was the first sample, and we just did like 22 of these. Are all of these numbers the same?
No.
Are some of them the same? So if I click it again, then again, that represents an average of 10 baseball players right there. Okay, you guys understand? So if I do it again, now I've just generated another sample. And I get a different value, which makes sense because they went out, they gathered 10 baseball players, gathered their salary, and what that average is, put it on a picture. You guys understand what's happening? So if I do click on generate 100 or 1,000 samples, what's this one going to do? 1,003 samples. These are not individual baseball players, these are just their samples. So now we get a picture like this, right? So if we do it again, and then we keep on doing this, we try to break their server. How would you describe this graph? Right skewed, left skewed, symmetrical?
Right.
It is right skewed. And is that any surprise? When you look at this picture right here, how would you describe this? It's definitely right skewed. So this guy right here makes sense that this is also right skewed. However, is this as strongly right skewed as this? No. So there's actually something that's going on here. What was this average? So this average up here, this is the average of all my samples that I've taken. So, but one thing at a time. So my average up here, again, this is, if I had one of you guys add all these guys up and calculate that average, that would be here, right? I know, right? Because she's sneezing. Let's all stare at her, see how much blood we can get into her face. Okay, does this make sense? If I added all these up and divided by 21, I would have an average here. That's what this is. Oh, this must be brand new. That's mu of x bar. This is the average of all my sample averages. Over here, this was my population average. So in relationship, right, this is mu. Can you guys get a decent idea about how mu and mu of x bar are related? Look at yours. Are they far off or are they very similar? Are they the same? Anybody have any that are the same?
No.
So generate a few thousand more and see what happens. Does that average change?
I can do it.
Yeah, mine stopped working too.
We just broke their server. I mean,
No, it doesn't change.
one of them works at Penn State, so let me see. Carrie Locke, and then Robin Locke, he's out in California, so we're not 22 something people doing this. So anyhow, okay. Does this kind of make sense what I'm doing? Now, what about this? This guy right here, this is my standard deviation. So this is sigma. They are very different. This standard error is actually sigma of x bar. Standard error is another common term for it. I will never call it standard error because none of you guys are going to be statisticians. And I have drilled in you standard deviation describes what? Spread. Standard error also describes spread, but it's specifically for averages. And rather than have you guys memorize another term, it's easier for me just to go, well, that's just the standard deviation for the averages. And it's easier for you guys to remember that. So those two values, are those two numbers the same? No. Are they even remotely close? No. All right, so what I want to do now, let's reset this. And instead of doing 10, let's have you guys do 20, you guys do 30, you guys do 40, you guys do 50. So up here, sample sizes, change it to what did I say? You guys are doing 20, you guys are doing 30, you guys are doing 40, you guys are doing 50. So change the n inside the sample size to 20, 30, 40, 50, and then just generate a whole bunch of samples.
By 10, by 1, by 100?
Thousands. Generate thousands. So n is equal to 30, and then just generate 1,000. Just hit it a whole bunch of times, and then just stop and wait for it to catch up.
So I got to 12,000 and that.
Okay, well then just stop. That's fine. That's plenty. Okay. So now what I want to do is, remember, we started off as a heavily right-skewed graph. You guys over there, is your graph still right-skewed?
Yes.
Yes. But is it as right-skewed as what I just had?
No.
So it's more center. What about you guys? Is it still right-skewed?
Yes.
Probably just a little bit though, right? What about you guys? Is your
Same.
graph still right-skewed?
Yeah.
Kind of, but more in the middle.
So it's
More in the middle.
slightly. What about you guys? Is your guys' graph right-skewed? You sure? Let's see what happens. Let me change this.
Never mind,
Let's change, what did I have you guys do? 20, 30, 40, 50. Let me try to do 50. Then I'm going to generate that.
Yeah, y'all just way more centered.
I didn't, it changes the.
What about this? Still right-skewed?
I wouldn't even go as far as.
Really, really close. So now let me change this to 100. Oh wait, I have to. Okay. What about this?
No.
Is this still right-skewed?
No.
It's not. In fact, now that my sample size is larger, is this more like a normal distribution?
Yeah.
So that's pretty interesting, isn't it? Because over here, is this normally distributed? Is this picture over here normally distributed? No, it's heavily right-skewed. Is this normally distributed?
Yeah.
Roughly, yeah. Although if we did it with, what did I have you guys do it at, 20?
20.
Your guys is what isn't going to be. Is that normally distributed? Pick a different data set. Pick, I don't know, something along over here on the left. Pick one of them. It makes no difference which one that you pick. I'm gonna do Hollywood movies. And I'm gonna change this back to, change your sample size to 100 and then just generate a whole bunch of samples. There's a drop down in the upper left.
Doing the basketball players.
Wait, we're changing the sample size to 100 and what else?
Then just, change the data set in the upper left.
Okay.
Change it to anything that looks good to you. Change your sample size to 100 and just start generating samples. Because I want to know, regardless of the data set, we all should have a normal curve. Regardless of the data set. I can guarantee all of you guys will have a normal bell curve if n is equal to 100, and it doesn't matter what the data looks like. It is completely predictable. Every single time. It's actually fascinating, isn't it? Because over here, in order for us to do this question, you had to be told that it was normally distributed. Right? In fact, right, I'm that ass. I had 2 questions. I'm like, oh, you guys knocked this one out, and it should have taken you like 15 seconds. You guys go through and you read for the word normal, and you're like, it doesn't say normal, I can't do it. What about this? Does this one have to say normal for you to do it? No. The only thing that matters is you just have to have a large enough sample size, and if your sample size is large enough, then you can still do this, whether it says normal or not.
So, are you gonna put numbers like higher than 50, like, is
Yeah,
there a number that we should be looking for?
there is a number that you need to be looking for. Okay, so the conditions for this. These are the parts that we have to check now. So, number A. Either we have to have a random sample, or the sample has to represent the population. Basically, what we're trying to do here is we're trying to reduce bias. Letter 2. With this, the sample must be less than 10% of the population.
The sample must be.
The sample must be less than 10% of the population.
Professor, the first one says random sample or what?
Sample represents the population.
Represents the population, and then that's to do for what bias?
This is just to reduce bias,
Reduce bias.
right? So if it's a convenient sample, then it doesn't work. Here, if my sample size is too much of my population, then it doesn't work.
It has to be less than 10%?
Less than 10%.
I think you go.
No, that's less.
than 10%.
That's less.
So for the, do we have, like, will it tell us how big the population is, or will it tell us it's less than 10%?
You'll have to just assume it.
Just assume.
Yeah, you'll have to do like some type of, okay, so this is a run. My sample seems like it's good enough to be less than 10%.
Okay.
I'll show you guys when I get to that other example. Okay. This guy right here, again, is just to reduce bias. This guy right here is if my sample size gets to be too large, then I end up getting an unnecessary bias in my sample. So again, both of these guys right here are to reduce bias. They're also gonna help out with the math. 3. This is the normal distribution. So, there's two things that we can check. If the population distribution is normal, in other words, if you're told someplace inside the question that it is normally distributed, right, like those questions right there, it had to say normal distribution. If we are told that it's normally distributed, then the sampling distribution of sample means, sample averages, is also normal. So if we're told that it's normal over here, if it's someplace inside the question that it says this is normally distributed, if this is normal, then my sample averages are also going to be normal. That's not actually what we've shown up there. Because up here, this is my population distribution. Is this normally distributed? This is not, this is right skewed. Is this normally distributed? Yes. So, regardless of whatever the population distribution is, the sampling distribution will still be normal as long as your sample size is large enough. Or Magic number is 30. If the sample size is larger than 30, then the sampling distribution will still be normal, regardless of whatever my population distribution looks like. That number 30 is actually highly debated. I've seen it as low as 10, I've seen it as high as 50. I believe that all the homework, the online in this particular author uses 30, that's what I'm gonna go with. These are the conditions that we have to check. Then, what do you think the third step is? Begins with an M, ends with an F. Oh, that was not a curse word either. Is the map. For this map, it is no longer X. It's no longer an X. This is now an X bar. Then, how do we finish it?
Would this still be, is there still a between for the map on this one?
There is, but I never asked. It's always either greater than or less than. Because what you're trying to do here is you're trying to see how usual or unusual a sample is. You can also use this for super long time ago I worked in a practice. You could actually use it to tell whether something is like within normal ranges or outside of normal ranges, so you need the machine to be calibrated. That would be an indicator. And there might be a homework question about that. I don't remember. I was really confused.
I'm sorry.
I thought that like something like we're getting invaded by like.
It scared me.
Okay, good. Someone was the only one. Okay.
Something was opening, I was like, what is
I know.
happening to the school?
I'm like, well, since you guys don't understand this, it doesn't matter anyhow. I am faster than all of you. I am faster than one of you. Okay.
I was so nervous just now, what the hell is going on? Holy shit.
Okay, so there's a couple more things that I have to get to. So, again, this mu is very, very similar to this mu of x bar. And in fact, for us to make a sketch for this, which we can do, since we know it's normally distributed, since we have an average, since we have a standard deviation, we can say that mu of x bar is actually equal to mu. This is in theory. And if you look up there, those two numbers are similar. If I would do enough samples over and over and over and over again, then they would actually turn out to be identical. So this one is usually really easy to do. Now we also have this, right? This is the standard deviation. This is describing the spread of the groups. So over here is this standard deviation the same as this standard deviation? No, and in fact they're massively different. So unfortunately, sigma of x bar is not equal to sigma. It's really close though. It's actually equal to sigma divided by, this is where all of you guys sigh heavily because you're divided by.
Oh my god.
Oh my god, Professor, are we gonna really do this
I
part
don't
for
have
real?
that much room. I don't like them.
How do you put that, hold on, how do you put that in the calculator?
Square root of a number.
Can you start sharpening your pencil again? Cause that scared him, so I'm just wondering if he can just undo what he just did. So this is
No, this is if, for us to make a sketch, we can make a sketch using this. You will have to use a calculator on this exam, unless you guys are awesome at doing square roots. I can do square root of this. What's my sample size of this?
100.
100.
What's the square root of 100? 10. This is 5.37. What's 5.37 divided by 10? I already gave you the answer. What's 53.7 divided by 10? 5.37. So this is going to be very similar to 5.3.
This is what would end these like
The sample size.
Okay.
And,
Yes.
Okay, so n is the sample size, and the mu x bar equals mu, because that's only in that specific instance, and it's less than 3 1 30.
If it's less than 30, then none of this applies.
And then
you would be doing what we did.
Oh, so wait, and it's
yeah, can you say that again? And is the sample size? Okay.
Yeah.
So just to re-clarify,
So fucked up and it's cool.
mu of x bar is the standard deviation of the averages of
Mu of x bar is the average, not the standard deviation.
Oh, okay, so, that, and then that is the mu of the average divided by the sample size.
That is the standard deviation divided by the square root of the sample size. Okay. Okay, so like I said, I know that you're massively confused. This always happens, but let me walk through the steps. And I actually don't want you guys to take any notes for this, because I want you guys to feel better about this and see, like, look, this is where you will be, and you guys are farther along than what you think that you are. But if you're constantly trying to write stuff down, then you're back there while I'm talking over here. So I need you guys to be with me for a second. Okay, so back to my super awesome, right? I'm selling a bunch of cigarettes. I'm trying to kill everybody, get everybody addicted so that I can move to Aruba since I can't win the Powerball.
Well, you don't play, so how
Oh, yeah. I know, but my wife didn't even play. I was like so disappointed.
Aw, she didn't give you a chance.
I know. Alright, so the nicotine content of my cigarettes has an average of this. So this is mu. And a standard deviation of this. This is sigma. If 100 is 100 larger than 30,
Yes.
so I can do this. This is n. Of these cigarettes are analyzed, what is the probability that the resulting sample mean nicotine content will be more than 0.84?
What's that?
What's what?
That little arrow with the carrot.
That's supposed to be an N.
That's the end.
My fault.
Do you want us to write this down?
No. Alright, right? This question is now, since I see a sample size in this, I know that this is x bar. Right? So this is let x bar. So what does x bar describe? The average of what?
Average.
Average of sample.
Average nicotine content of
100.
of my smokes. I say of my smokes, does that make it cool?
It sounds so old school and sad.
Alright. Conditions. The first condition, is a random sample taken?
No.
How do you know? Does it say anywhere in there that a random sample was taken?
No.
Does it say anywhere that the sample represents the population?
No.
Okay, so then we have to assume this. How about
Oh.
SIGs? Does that make me cool?
Yeah, that's I guess.
Assume a
Random sample.
Random
sample
sample.
of 160.
That takes care of this.
So,
Yes, I'm addressing the bias.
so
So even if it doesn't say random sample, we just have to
You just
assume
assume.
that it, okay.
That's going to come under, like, I'm gonna finish the entire thing, but if I think that this situation is violated, then that would have an issue with the part B of this, which I will get to. After we get on with all this, I'm going to ask you, do you believe that my company is doing something wrong?
Okay.
That's what I'm gonna ask.
So that's an opinion. Or
Except for, it's based on statistics, so it's not really an opinion.
Okay.
We are going to gather information, you're going to decide whether I am doing something wrong or whether I am not. That is literally what statistics does.
and that's what the statement will be.
That will be a whole other question. But one thing at a time, everybody understand this random sample.
So far, yes. We're
Right.
assuming right now.
Letter 2. How many cigarettes do you think I possibly make? Billions, right? That's how I don't know.
So you sold it to everybody, yeah.
Yeah, right. So is 100, is it safe to assume that 100 is less than 10% of all my cigarettes?
Yes.
Okay, so
It has to be.
safe to assume 100 is less than 10% of all my cigarettes. Before I go on, what is my sample here?
The 100 cigarettes.
The 100 cigarettes. What's my population?
All
All
cigarettes.
cigarettes. You see how, look at how awesome you guys are doing that, right? We are literally, by the way, this is true, we are literally at the halfway point of the class. Look at that, you guys are 14 classes in, and look how quickly you guys can pick up a sample versus a population. That's why I have to ask you on every single exam, what's the sample, what's the population? Both of these, right, this guy right here, I include the sample in it. This guy right here, I include the sample and the population in it. Alright,
I have a quick question.
Yeah.
So is it like all cigarettes or all with the?
all mine.
Yeah.
It should be all mine, but I'm okay with this.
Oh.
Alright, letter 3. So with this, am I told anywhere up there that it is normally distributed?
No.
No. But since 100 is larger than 30, since 100 is greater than 30, this is what I would ask. The sampling distribution, yes. Of sample averages is normal. Right, you guys understand? Since the 100 is larger than 30, the sampling distribution of sample averages is normal. That's all I've done. If it's, right, so if it's lower and it doesn't say normal, can you do it?
No.
No. If it's lower and it does say normal,
Yes.
yes. 'Cause
Wait.
you were told that it is normal and it is lower than 30, the being told that it's normal supersedes the 30.
Yes.
If it's greater than 30, you don't care.
Yeah.
So those are the two things. If you're told that it's normal, you don't care about the sample size. If it's larger than 30, you don't care if you're told normal. Is that okay? So, what is mu of x bar here? It's mu. So it's this. That is 0.8. What is sigma of x bar here? It is 0.1, because that's my standard deviation, divided by the square root of 100. The square root of 100 is 10. 0.1 divided by 10 is 0.01.
Oh my god.
It's normal. I have a mean. I have a standard deviation. I can make a sketch.
Can you write the little formula next to it?
There was a girl who was in the military in my class once, and she did all of her notes on the fly in different colors. And if I did that, you remember how I had you guys sigh? she sighed. So every single class she just, jeez, and she was like a perfectionist with her notes. It actually made me laugh, but I tried super hard not to do this. Anyway, okay. From this, I can actually make a sketch, but before I get to that, 3. The math. What am I asked to find?
If it's
X bar is greater than 10%.
0.84.
0.84. So let's pause for a second. If this is the average of all of them, this is, I'm trying to see how unusual it is for me to get one sample that has an average value of this. So this is a number that describes a sample. This is an X bar. A number that describes a sample is called, yes. The number that describes a sample is called, yeah, it begins with an S. Ends with the statistics. Right? It is a statistic. These two up here, what are they? They are numbers that describe populations. Those are parameters, right? They are numbers that describe populations, so they are parameters. This is why on every single exam I have to ask you, is this number a parameter or is this number a statistic? So I can make a sketch of this. What is the number that goes down the middle of this?
The average.
0.8. Oh, I think I can get it. This is like 80 cents. And then like me adding 1 penny.
I didn't think about
So what is this one? 81. Yeah, that's like okay. That's like
18.
Where do I shade? Above it or below it?
above.
Above, because it's asking for more than. So I'm shading all this. What's my answer going to be? Huge or small?
Very small.
Very, very small. So when I give you multiple choice answers here, which one are you going to pick?
The
The
littlest one.
smallest one. Now, great snap that. I'll give this to you guys. I just didn't want to give it today. Let me go back over here to. Oh wait, no, I'm not done. She was just taking a picture of this. I will give this to you, right? And we will go through all of these. I just want you guys to, because there's a lot of anxiety whenever I do this, because you guys are massively overwhelmed, because it seems like I'm throwing a bunch of stuff at you. But now that I'm 3/4 of the way through this, am I really adding a bunch of stuff to you?
It's just switching with things.
Yes. That's it, yeah. So let me go back here to sold. Disengage. Is it this one? Distribution, normal distribution, what's my mean? 0.8. Oops. What's my standard deviation? 0.01. And then I want greater than, so I want right tail. And I want this to be 0.8. 1, 2, 3, 4, and then a 3. One, 2, 3, 4, and then a 3. Is that a very large number?
No.
No, did we expect a very large number?
No. You're gonna give me one source as multiple choice.
Just like what we did last time.
You have to count them zero.
Oh, well, no, because what I do is I do this, and then I do like a 99, because that's how I knew that your answer was wrong, because you did the wrong answer. So then I do like 0.9997, because that would be everything less than. Then I do like one like 0.54 or something like that, something in the middle. So then it has to be like one of those 3. All right, is this okay?
Mhm.
Now, what's the last thing we do? Okay, so what do you want to do? Do you like the if then, or do you want to do just what we found? And then I'm not giving you guys a choice. I'm going to be like Apple and make all the decisions for you, and you guys are going to love it. So, I am going to say what I found, and then I'm going to say what I assumed. So, what did I find?
That
What was the question that I was asked?
the probability.
What is the probability that the resulting sample?
So 100.
So, the probability of randomly selecting 100 cigarettes with an average nicotine content of 84 G is 1, 2, 3, 4. So, okay, so before I get to the assuming, right? In my statement, how much of my statement is different than what you guys just got in doing there? I don't think that anybody put the 100 cigarettes. You guys would just put randomly select an apartment, or randomly selected a pregnancy, or randomly selecting a, or whatever it is, a test. And then you also didn't have the average. So it makes sense for us to include this now because this question is about an average. Assuming, so what is the information that I was given? And was I told that it was normally distributed?
No.
No, so I can't put it. Right? Nowhere in that question does it say normally distributed, so I can't put it. I flat out cannot put normally distributed. Do I know what the average is?
Yes.
I was told that. Do I know what the standard deviation was?
Yes.
I was told that. So assuming the average nicotine content of all is whatever it was, 0.8, and the standard deviation is 0.1. It was 0.1. It is not the 0.01. Because that's the sample. That is the sample standard deviation. You guys see how there's a bunch of stuff floating around here? This, and I understand, like, there's just enough to make this like, oh yeah, totally understand all this. And then there's another enough to make it go, nope, I have no idea what's going on with any of this. Okay, yeah.
So for the sketch, how we had to put for the ones before that it was normally distributed, the mean and standard deviation. Do we still put the mean and standard deviation since we can't say that it's normal?
Right. Is that what you're talking about? Oh no, you're talking about the sketch.
No, the sketch.
For this?
Yeah.
This is certainly normal. In fact, I said that it was normal.
Right, but you said we can't put that in the statement. So before, like with the other ones, how we could say n in the parentheses,
Oh,
100
right.
comma.
No, this
none of
guy right
that?
here would be n and 0.8 and 0.01.
But we can still put n.
Yeah, because this is normally distributed.
Okay.
Not the population.
Okay.
Right, they are different.
So we're converting it from a population to a sample.
Yes.
And then doing the statement, so our statement has nothing to do with the population.
Or no, our statement has everything to do with the population,
not the
nothing
sample.
else. Yes, for the assuming,
For the assuming.
just for the assuming.
Okay.
Right?
Wait, can you say that again?
Like, this is population.
Okay, cause we
and
can't
this
write
is
it down, so I'm
sample.
trying to.
This is a population, and then we're converting it to a sample in the math. The assuming has everything to do with the population and nothing to do with the sample.
Oh.
And then,
And
the,
then that has to be
got.
yes, and then
yes.
the answer we have is about the sample.
Okay.
Okay.
Yeah.
Can I just suggest,
Yeah.
is there any chance that you could record this and upload it yourself? And we could delete it sometimes.
It's really hard.
It's time to like.
Yeah. The reason why is because like even if you record my voice, still being able to see what is on the board
Right.
is really, I've tried recording it, right, I have a camera there, but then to spin it across. I had an Army student that was deployed and went out to South Dakota, right, and she still wanted to attend, and she wanted to be able to see this, so I recorded all this stuff, and this, well, actually, she just never ended up watching any of them, she just dropped from class, but it was a fun experience for my end. But yeah, that's why I'm like, to be able to see it. The other part behind this is, I will give you a blank version of this. Like, I will give you a completed version of the sampling distribution question. I think it might be the same as this one. Oh no, this is the one. So we will have that soon. We're just not there yet. Okay, is this terrible?
Yes.
Yeah, it is, Professor.
Yeah, I know, and
The
like
statement is the worst part.
I was happy here, like.
It's just all this.
I was happy, yeah, and then I started frowning. When you got the red, it's the red.
Yeah, the red dampers the red. Once you hit the red, it starts to skip
All
right
the
there.
red.
It is all the red.
Right?
Once you got to the red, I was like, whoa. And I know you're saying it's supposed to be like the same, but in my mind and in my heart, it's not. It doesn't feel like that.
it's very similar.
And this condition part is crazy.
It's the conditions are always the same. Always the same. Random sample, less than 10%, then you're checking whether you're told or whether it's greater than 30.
So when you give us a question for the conditions, do we have to write down everything, or will you give us like the question?
You'll have to write it.
Wow, oh man.
Okay.
So is the statement done?
Yeah.
Like that's just how. Okay.
Well, at least the statement was short.
Yeah.
I forgot it.
Okay, you got it.
Yeah, that's why you do the meetings and everything. Alright, the other part, I will give you the written formulas on the exam.
Thank you.
Okay, that's a push, y'all, that's something, y'all.
Gotta end it right. I'll put this on the very top of the exam, and of course I'm snarky, so I'll put like possible useful information. I'll put this directly on there, so you do not have to memorize any. There's enough here that is still, I understand. Now you guys get an idea about how this exam is harder. It's just harder. This material is just
It's so similar but so different.
right, and you guys are so new at this. By the time and the steps, they never change. They'll never change. So by the third exam, it's still going to be the same 4 steps. We're still going to have the same conditions, and then you'll be like, okay, what's the first condition? And you won't be like a bad 5th grade choir trying to sing and rap. Random sample, 10%.
I think it would be more fun if you could convert this into a song so we can remember. I think you should sit down, pick
No
a
way.
Taylor Swift song, and be like, boom, boom, boom.
Not doing it. I have some type of dignity that's still left. I'm not totally cashing it in quite yet. Okay, my plan for this is, I'm actually kind of glad that I got through this. So if you guys want to copy this down, I will leave it here. If you guys want to take pictures and keep it forever, however it is that you guys take notes, do this. Next class, I'm going to give you this worksheet so that we can go through these and we can do one together. And then I have to turn the page to the other type of question, and then we have to do one of those. So that on Thursday, then we do another one, and then I tell you about what's going to be on the exam the following Monday, or the following Tuesday. This class flies now.
Yes.
It flies. And if you look at the schedule, there's 3 days per topic. After the exam, it's 3 days for confidence intervals, 3 days for hypothesis tests, we take another exam. We have 2 days, and then we do the final. I mean, this is like the home stretch. Once that you guys get this, the sooner that you get this, the better it is.
Wait, hold on. You said the next test and then the final. I thought there was. Hold on. So there's only one more test and then the final?
There's 3 exams and then a final.
Oh.
Just more tests.
I mean, it doesn't be full more.
What's like the average score on a final?
On the final?
Yeah, his class.
Do you really want to know?
Yes. Yes.
It's in the 65.
So how does one pass this class?
How many people have to take this class?
How are you getting anything at this point?
I think it's 30.
Okay. What did you say was 65? The average final. Okay, yeah. Great.
No, but Professor, honestly, What is your, like, what do you, I can't even think.
She's stressed. Something just happened.
What is that?
There's a lot of bubbles floating.
That's why the second exam, like the sooner that you guys get this, the better off it is. The third exam, students usually do really well on.
So it's safe to say that this
So we have a
year
chance.
is a crucial
We have a
turning point.
chance.
You
This-
get down pat
yes.
before.
Yes, that's why I started doing this last class. I had to get to the 4 steps as soon as possible. The sooner that we get to these 4 steps, the better off that it is for you and the more practice that I can get you. That's why there is, and I don't have any time. I flat out have no more time. That's why I say attendance is so, I'm not gonna go back anymore. I mean, every single day is a new topic, and I have to keep on moving forward. So, by the time that you guys come, and I know that you guys aren't going to like rewrite your notes or anything over the weekend, right? I'm not that naive. But before you come into class, gather someplace, somewhere, and go back through this same conversation. Go back through these steps. It'll help so much. I mean, that's why I've had you guys working in groups. Get with your chums. Look, here's what this is. Here's what this is. Do you remember what this is? Do you remember what this is? So that when you come back in on Tuesday, that you're like, all right, let's see if I can leave with a cramp in my hand, because ideally I would like to do 2 of these and then knock out 1 with the proportions. That would be ideal, and that's only 3 problems. So hopefully to get that done in an hour and 20 minutes, and it'll take some work to do. So
So we're gonna come back to this Tuesday?
Tuesday,
Okay.
I'm hoping to do 2 of these. I'm hoping to do 1 with you to say, hey, you guys remember how to do this? And then you're like, no, I don't remember how to do any of this stuff. And then, oh yeah, someplace throughout that you guys do another one that sort of more on your own, kind of like with what I was doing last class. And then we can turn our page to proportions. So we gotta get that, we have to get a proportion example done this Tuesday, so that we can practice it on Thursday, so I can tell you about what is gonna be on the exam on Thursday, so that you guys can take your exam the following Tuesday.
Will this be on Blackboard then? Those questions?
I have nothing up there right now, so don't even stress about any of this stuff. Review your notes before Tuesday, right? I don't want you guys to do any of this stuff.
The homework is on.
The online homework is going to be, yes,
So,
it is going to be heavy on the math. No, that's not due until, yeah, that's not due until the day, it's the day of the exam.
So the first
Yeah.
is the first.
Alright, you guys have a wonderful,
That second.
whatever